Scott Marcus is here from Genuity, our first speaker this afternoon.
Thanks, Sue. Yeah, I'm going to be talking about primarily utilization of IPv4 addresses. This is a topic that's been of interest at the IETF and also here. Now, in doing that, I'll be actually touching on three areas. One of them is to provide a little background on why the RIRs, the Regional Internet Registries, got strongly interested in doing this kind of proactive, ongoing forecasting of the rate at which the identifiers were being consumed. Second, I'll be briefly presenting the main findings of the work that we've done to date. And third, I'll be touching on something called the McFadden-Holmes report, which is a separate piece of work that purports to express the rate at which IPv4 addresses are going. Now, for the registries, we actually sort of stumbled onto a finding last fall. The Regional Internet Registries ARIN, APNIC, and RIPE are responsible, of course, for allocation of IPv4, v6 addresses, and also AS numbers. And I would say in today's presentation I'm not really speaking for the registries, but I'm a member of the Board of Trustees of ARIN, so I'm very much plugged into the process. In any case, in the finding, what we discovered is that the AS numbers were being consumed on really it's a beautiful textbook trend. It's an exponential growth curve, and since there's only 64,000 of them, it was pretty clear cut that we would be hitting the wall around 2005. And this was checked against many routing tables, against allocation history data. Some very good people, including Phil Smith and Jeff Houston, have looked over the analysis, and it seems to be, it seems to be pretty clear cut. We're on a path where they run out in that period of time. We checked a few other issues like the correct curve fit. It was suggested by a few people that it might fit a quadratic rather than an exponential curve. We looked at that. It seemed to me that it was much more likely to track the exponential. And again, if you look, the blue curve there are the actuals up to October. The gray here is the exponential growth curve projected from the data to October. The pink stuff is everything since October, and it's sitting about as close to the projected line as you would ever ask for from real data. So, it seems, again, to be a pretty clear-cut result. Now, for us, that was kind of a wake-up call for the registries, but it wasn't exactly a wake-up call for the world, or didn't need to be. I mean, the important thing is this is not the end of the world. This is not the sky is falling kind of stuff. The AS numbers are important to BGP-speaking routers, but it can be fixed. And in fact, the IDR working group in the ITF is well along, the drafts are well along. It does need to get architected, it does need to get deployed in an upward compatible fashion, but there's time. Everything ought to work out. I should also add, the AS numbers are sort of a related problem to the routing table bloat that we've been hearing a great deal about, especially from Jeff Houston. That's a separate issue. It's correlated with this, but it's not the same thing. Okay, in any case, moving along. So within the registries, this really drove a strong perception that we needed to be tracking this stuff in a much more proactive manner. I know for me in particular, it was kind of striking that an identifier that we were responsible for administering would be running out in 4 years, and that it hadn't really been noticed. So what we did was to put together sort of a blue ribbon team to do analysis of this type. And also, what we've begun to do is to take the data of allocation, the allocation records maintained by 3 separate global registries, 3 separate regional registries, put it into a consistent format, and put it up in public view so that independent researchers can look at it and evaluate it, and without having to know the vagaries of the individual registries. And that process at this point is well along. Now, the team that we assembled includes Frank Selensky, who you'll recall was the person who drove the ALE process, the Address Lifetime Evaluation, back in the early 90s, KC of CADA, and I'm there sort of to get resources as needed out of the registries and make trouble when need be. This process had very fine support from all 3 of the registries. Basically, the idea was that we'd be doing proactive projections on a regular basis and also making the data available. Mostly, though, trying to stick pretty close to the measurable numbers, not to get too far into speculation about marketing trends. Now, some key findings are, first off, the size of the allocations. This represents the allocations per year. And the data, as you can see, are a little hard to extract a lot of sense from in this form. The most obvious point is that the amount of address space being allocated in years past is a lot greater than what's being allocated today. Much clearer is the cumulative graph. And here the yellow or cream colored are the allocations attributed to ARIN. The green is RIPE, and the purplish color represents the Asia Pacific NIC. Now here you can see that, say, in the late 80s you've got something that feels like an exponential growth curve, but starting in 91, 92, the period where the registries applied much tighter control to allocation, not only does the trend change, but if anything, the second derivative is negative. It's actually sloping down. This is not exponential growth. Now, the team put together a number of estimates. A simplistic kind of linear fit would show exhaustion really pretty far out. Recall that there's slightly less than the 4 billion you'd assume. There are various blocks that are not available, but still, there's quite a while before you hit the wall in a model like this. The correct formulation, the one that you would really expect it to follow, is something called the logistic curve. And as you can see, the logistic curve really should go nearly flat. A better view of it actually is here. This work, by the way, was done by our colleague Frank Selensky. Bless his heart, he did the heavy lifting on this stuff. And as you can see, the logistic does seem to be a pretty good description of what's happening. Now, with that said, well, actually, let me move on for a second. This result is consistent with a number of other measures. What I just showed you is based on allocation records from the registries themselves. This is the addresses allocated. If you look at address growth within the routing tables, and this comes from Jeff Houston's data, again you see an upward trend, but it's a gradual trend. The blue line there represents his raw data. The pink line is cleaned up to take basically to eliminate some announcements of Class 8s that sort of pop in and out. So the pink line is the one you'd want to see. Again, another way to view this is the addresses in use where the red line represents the allocations. The blue comes from Jeff Houston's data and represents the addresses announced. The green line is sort of an interesting cross-check in its own. It represents data from Telcordia's NetSizer service, which tries to estimate the number of addresses in use based on the number of permanent reverse in-adder mapped addresses. Also interesting to note that the addresses, as reflected in the routing tables, again from Jeff Houston's data, are a gradually increasing percentage of the total allocated, as you'd expect. Okay, now here we come to a little different point, and I'll be spending just a few moments on it. How many people here have seen reports in the press or at the IPv6 forum, perhaps, claiming that IPv4 addresses would be exhausted by 2005? Can I see a show of hands? Okay. Now, where that data came from, I believe, is a report prepared by actually three individuals, McFadden, Holmes, and Paul Millat. And in it, they've done an interesting analysis of address consumption. And it comes to a radically different conclusion, of course, than the numbers that I just showed you. And so I think we really have to address the question of why. This is one of the figures from it. And the three curves represent what the report claims to be a most optimistic rate at which the addresses are being exhausted, a most likely, and a worst case, one that's consistent with most rapid exhaustion. And these tend to assume that they would indeed run out between 2004 and 2007. The problem is that those curves are actually based on an assumption that the rate of growth would be 30%, 50%, or 80%, and again on an exponential growth curve. Again, the actual data don't say that. The actual data that we have from our study would put the number in low single digits, probably about 3% per year, and if anything, declining. Jeff Houston's independently estimated this based on routing table statistics and came up with about 7%. And based on the fact that what he's capturing is a slightly different number than ours, I think that that's perfectly reasonably in agreement with our data. In this case, I think that they're basically making an assumption of an incorrect rate of growth and therefore reaching an incorrect conclusion. It's a personal opinion. But in any case, what it says is I believe that the report has to be taken with a grain of salt. The other part of the report actually is more what I consider a marketing analysis, estimates that based on the rate at which internet wireless access is going to be increasing, cable and other things, that we should need this many in the future. And basically, that part of the report is speculative. And also, the assumptions in the report are not well documented, not well substantiated. I think there's really not enough there to make a clear challenge on it. In any case, I think the key point on it would be, I think that the report is reaching conclusions that should be taken with a large grain of salt, because they could lead people to do things that are probably not good. Okay, in any case, as far as the team that's doing this kind of analysis for the RIRs, I think the lessons that we take away are, first, that we're going to want to maintain careful, quantitative-based analysis, that we would want to continue to keep away from speculative work and to really deal with the numbers. I would say that I think that the fact that you've got reports like the one I just referred to coming out, in a way, is actually a very healthy thing. It's good that people are getting interested in the problem. It's good that people are looking at it. And I think debate has always been healthy in this community. I strongly believe in letting 1,000 flowers bloom. One of the things that we're doing actually to support that kind of independent analysis is indeed to take the allocation data from the registries, put it in a standard format, put it out there. And in fact, my understanding is that the ARIN and the APNIC data is out today. The RIPE should be along shortly. We're working to make this happen. Meanwhile, basically, the policymakers in the various organizations should be looking at these studies and making their decisions, kind of factoring them all in, deciding which ones they want to give credit to and which ones they perhaps put less confidence in. Any questions?
Hi, Andy Ogielski, Renesis. Well, one point that may be true is that the situation is not stationary. Ramesh Govindan did a pretty good job 94-95, looking at the number of ASs gross per day over about a year's period. We have done similar analysis in summer of 98 and got the same results. So between 94 and 98, the growth of the number of AS numbers in the BGP tables was strictly linear, 3 per day. Okay? There is a change. There is a kink in your data. So you may now fit it to exponential, but it didn't look like exponential. In contrast, in the same period of 94 through 98, the growth of the DNS recognizable IP addresses was strictly exponential. So there is a real qualitative change in the behavior. Do you have any comments on that?
Well, actually, I've got a question. If you're saying that the growth in the rate of prefixes was strictly linear, I think the data supports that. For the growth in number of ASs, the data back to 96 at least has a very, it seems to me to have an excellent fit. It's got R squared of 0.995 or so with exponential going back to 96.
I think that it's a small piece is hard to argue whether it's exponential or not.
Yeah,
I only refer to 94 through 98. Yeah.
Okay, actually I'd agree. In many cases, on a small time scale, it can be hard to distinguish the two.
Yeah.
Back to 96, the fit is good exponential, but it's possible it would have also had good fit linear. In fact, in the same way that you saw that the quadratic actually had a pretty reasonable fit for a period of time as well.
All right.
So it's a fair comment.
George Michelson from APNIC. Do you plan on trying to factor in any economic analysis on the effect of the dot-com downturn and the impact that might have on resource consumption? Because it does seem to me that this is an economic domain, and this is stuff which is not necessarily going to have a consistent model, and we have to take account of cyclical processes like crashes in the economy or changes in allocation policy and their effect.
Again, it's a good question. If you look at the routing table growth graph, there's an interesting thing that happens just in the last few months, and that is a certain flattening. And as probably many people here know, this has already been discussed on the NANOG mailing list. I know Jeff Houston believes that this may be a solely local phenomenon to Telstra. It seems to me that the same kind of dip from December to today it seems to also be visible in the similar statistics that Tony Bates keeps, and it looked to me like it's also visible in Phil Smith's data. It was a little harder for me to be sure of that there, but I see Phil is nodding. So frankly, I somewhat question Jeff's contention that it's a purely local phenomenon, and the natural thing to attribute the dip to is indeed the economic conditions. So I think they are important. I would say I think it's a good thing for people to be looking at this problem. For the little study group that we have, I don't see us doing economic analysis. It's sort of not our area of expertise, and it would probably get a little more speculative than I would think we would want to. But implicitly, that'll be showing up in the numbers, and the numbers, I think, are fair game. Yes, John?
John Baum. My question is that I noticed in one of your pictures the allocation graph was fairly large for the for the ARIN side, and it looked like it was much smaller amounts in RIPE and the AP regions, if I interpreted that correctly. Given that, what do you think is going to be the exhaustion issues as countries like China and other places really start to come online mainstream as far as IP allocation and its exhaustion?
Well, another good question. It's a potential issue, and it's one that requires close watching. The lowest of those three curves is APNIC, and it's a small fraction of the total. Now, if you look at the data, it actually turns out that the allocation data was pretty big years ago before the registries really were fully throttling back on the allocation. So it's not entirely a consistent trend going all the way back. But if you track it back to about 1996, there's a growth curve for Asia Pacific that could very well be an exponential growth curve. And that curve would be consistent with consumption of about 250 million addresses between now and 2005. That's not big enough to put us completely in the tank. Right. It doesn't exhaust what's there. It's something where if it continues to track what may be an exponential growth curve, then it's a cause for concern. It's certainly something we need to watch.
Thank you.
Yeah, Scott, I'm in fairly close contact with various folks in the IPv6 forum, and what they would say, and I'm not here to defend the point of view, I just want to make sure it's represented, is that the reason that the growth has slowed down is because of the allocation policies themselves, not because of latent demand. And the IPv6 forum is made up of people who believe that the address space would have grown more if it could have. And I certainly know of requests for /6 net blocks that were turned down in the IPv4 space, and there are a lot of people who simply cannot bring certain applications to market, or at least they claim they can't, and they're willing to spend money to enable this whole IPv6 technology thing. So, to the extent that it's sort of fun to poke holes at the claims that they've made, it's also necessary to maybe ask them to show records of times when they have asked for the amount of address space they thought they were going to need and they thought they could justify, and they were turned away. Because that graph, I think, would show a much worse trend than the actual allocation graph, which of course is being managed by registry policy.
I think there's no question that what we're seeing is, to a very significant degree, an artifact of registry policy. In fact, if you even look at the graph that's up on the screen, it's very likely that the steep part of the graph would have carried forward if the registries weren't attempting to keep a lid on allocation policies. And I think the point that you raise is a good one in another sense, which is that it raises the question, too. Through these policies, while they've been necessary to contain growth, there's a public policy question of whether they may perhaps have the impact of transferring costs to the wrong people, right? Which is a complex question, but it's a real question, one that can't be dodged.
Yes, you stated that the allocation rate for ASNs was fitting very well to an exponential curve.
Yes.
And that the prefixes that we're actually seeing in the routing table are a much flatter growth. Is that correct?
I didn't actually say that. I made the first statement that the ASNs are following an exponential. As far as the routing table prefixes, first off, I haven't personally been doing analysis on them. Second, if you look at Jeff Houston's data and analysis, he would argue, I believe, that since 1998 they're actually following a curve slightly faster than an exponential growth curve, sort of super exponential growth. I guess the last point is I was raising a question as to whether it's perhaps slowed to something significantly less over the past few months for reasons that maybe aren't fully understood.
Okay. The reason I was following that was, and not based on IP address allocation rate, was the statement that ASN growth is exponential. Brought the question in my mind is, when are we going to be when the majority of new ASN allocations won't actually be advertising any prefixes. So that's where I was going with that. Thank you.
I'm sorry, I didn't quite catch that. When the majority of ASN allocations won't be advertised?
Well, if the growth of prefixes that were advertised were less than the growth of ASN allocation, at some crossover point, most new ASN allocations would not be advertising any prefixes. So. But you're not saying that. So
yeah, I'm not saying that.
I don't need to say that.
I'm definitely not saying that. Thank you. Okay, thank you very much.